In this video we're going to talk about how to deal with complex fractions in various forms. Now in our particular class, this would be chapter 5 section 4, but it's just various types of complex fractions. Now when we look at a complex fraction, this is really saying 9/10 divided by 6/7. So we can rewrite it as 9/10 divided by 6/7. How do we deal with division of fractions? We multiply by the reciprocal. Or an easy way to remember that is copy dot flip. So we copy dot and flip, multiply by the reciprocal. Now our 9 and 6, those can be cross-canceled. They're both divisible by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Now I'll multiply. 3 times 7 is 21. 2 times 10 is 20. And we cannot reduce this any further, so our fraction is complete. Let's try another one. This one has a whole number divided by a fraction. Now these can be a little more confusing because it's sometimes hard to differentiate. Is this 3/2 divided by 3 or 3 divided by 2/3? When they're typed, you'll notice this line is slightly longer than this line. So this is 3 divided by 2/3. So I'm going to rewrite that as 3 divided by 2/3. Again, we need to change this to multiplication. So we're going to copy dot flip or multiply by the reciprocal. 3 can be treated as 3/1. So this will give us 9/2. 9 and 2 don't reduce, so we can leave it just in this way. Now we have complex fractions without variables. In our book, this is called problem type 2, where we actually have addition or subtraction in the numerator and the denominator. So what we need to do is we need to simplify our numerator and simplify our denominator before we can deal with the complex fraction. I need a common denominator between 3 and 5, and that denominator is 15. So I need to multiply this fraction by 5/5 and this fraction by 3/3, which will give me 5/15 minus 18/15, which will give me -3/15. Now I come back and I look at my denominator. Between a 2 and a 4, my common denominator is 4, so I only need to multiply that first fraction. And so I get 6/4 minus 3/4 to give me 3/4. Now I have a complex fraction I can deal with. So I have -3/15 divided by 3/4. Rewriting this as multiplication, I get -3/15 times 4/3. My 3's will each divide by 3, leaving me a 1. Now I have a negative times a positive, so that's going to give me a negative. 1 times 4 is 4, 15 times 1 is 15, so my answer is -4/15. Let's look at another one. Here I have a whole number and a fraction in the numerator and denominator. Now, to come up with the common denominator for my whole number, I take this numerator and I multiply it by my whole number, and that will give me my numerator, and then I use the same denominator. And as you can see, that 2 is the same as 8/4 because 4 goes into 8 2 times. and 8/4 plus 7/4 is going to give me 15/4. For my denominator, same general idea. I want my denominator to be 3. So I have 3 times 3, which is going to give me 9/3. So I have 4/3 minus 9/3 to give me negative 5/3. I'll rewrite this as division. And then convert that into multiplication by multiplying by the reciprocal. 15 and 5 will both divide by 5, giving me 3 and 1. And then when I multiply this across, I have a positive times a negative again, so my answer is going to be negative 9/4. And that one is complete. The next type of complex fraction involves a lot of variables. First, before I do anything, I'm going to look at each fraction inside the complex fraction and see if there's any reducing I can do already, and there's not. So I'm going to rewrite this as division. And then convert it to multiplication. Which means I multiply by the reciprocal or copy dot flip. Now that I've done that, I can start looking at cross cancellation. 5 and 10 both divide by 5. I have an A here, no A's here, but I have 2 B's and 3 B's. These 2 B's will cancel out with 2 of these B's, leaving me a 3. Between these two fractions, 14 and 7 both divide by 7. I have 3 C's and 3 C's, so those will cancel each other out completely. I have 1 D and 3 D's, so one of those D's will cancel out, leaving me 2. Now, just for clarity, because this is a bit sloppy, I'm going to rewrite this. So I have 1A, and that A is not really necessary, or the 1 rather is not really necessary, but over 1D squared and 2B. So multiplying these together, I get AD squared over 4B. And that is my final answer. As you can see, nothing else will reduce. We have one more problem like this. Checking inside each individual fraction, nothing will cancel. So I'm going to rewrite this as division. And then convert it to multiplication. So copy dot flip. Now I'm looking for canceling 5 and 10 both divide by 5. I have 4 C's and 3 C's, so 3 of these C's will cancel out 3 of these, leaving me 1. I have 3 D's and 1 D, so this D will cancel with one of those D's, leaving me 2. 7 and 28 each divide by 7. I have no A's on this denominator, but I have 3 B's here and 2 B's here, so 2 of these B's will cancel 2 of those, leave me 1. So now I'm going to rewrite this. I have 1 C and 2 D's over 4B. And in my numerator here, all I'm left with was an A over 2. So I get ACD squared over 8B. And that is my final answer. Okay. In some situations, we have complex fractions made up of expressions. Now, what I want to do is, before I start dealing with factoring any of these expressions, I'm going to go ahead and do my conversion into multiplication. And I usually rewrite it as division first, but you don't have to. If you are able to, you can skip straight to this next step. Multiplying by the reciprocal. I now want to factor these binomials. From 5x and 15, I can take a 5, which is going to give me x plus 3. And this is a perfect square, or sorry, a difference of squares. So I take the square root of each and plus minus. Nothing will factor from my second fraction. Now, as you can see, I have x minus 2 and x minus 2. Those will cancel each other out. And here I have 5 and 20. Well, 5 goes into 20 4 times. So what I'm left with in my numerator is x plus 3. And in my denominator, I have 4 times x plus 2. And that is my final answer. Let's try another one. I have x over x plus 3 divided by x to the 5th over 3. So that's x over x plus 3 times 3 over x to the 5th. Now, I don't have any factoring to do here, but one of these x's will cancel one of those x's, leaving me with 4. 3 and x plus 3 don't cancel. So I'm left with a numerator of 3, and then x to the 4th times x plus 3. And that is my final answer. Okay. Complex fraction problem type 4. We have a whole number and then a fraction made up with a variable expression. So if you recall, we just recently, a couple slides ago, talked about changing a whole number into a fraction. We pick the numerator and we multiply. So this is going to be 2 times x plus 5 over x plus 5 plus 5 over x plus 5. I'm going to go ahead and distribute that. Okay, and my numerator of my original complex fraction, I'm going to multiply by x. So I get x minus 5 over x. I can combine like terms to get 2x plus 15 over x plus 5 divided by x minus 5 over x. So that's 2x plus 15 over x plus 5 times x over x minus 5. I can't factor here, so I'm going to go ahead and do my multiplication, and I'm going to get x times 2x plus 15 over x plus 5 times x minus 5. And that's my final answer. Sometimes nothing cancels. Here we have another version of this with a whole number. That 1, I'm going to multiply by 5x and then give it a denominator of 5x. Which gives me a new numerator of 5x plus 8 over 5x. Now these 5x's are not going to cancel because you can't cancel with the 8. For my denominator, I'm going to multiply by 25x squared. So that's going to give me 25x squared minus 64 over 25x squared. And I'm going to convert that to division. Then I'm going to convert that division into multiplication. Now I'm going to look and see what I have. Right here, 25x squared is a perfect square and 64 is a perfect square, so I can factor this. So I have 5x plus 8 over 5x times 25x squared over the square root of 25x squared is 5x. The square root of 64 is 8, so I have 5x plus 8, 5x minus 8. I can cancel these 5x plus 8's, and also 5x will go into 25x squared, leaving me 5x. So my final answer will be 5x over 5x minus 8, and nothing else will cancel. And that is how you work complex fractions.